Hey class, let's talk about the last assignment, and so we'll focus on the first problem, okay? And if we have time tomorrow, and then in the class I'll talk about the second one here. So anyway, the first one is an Excel exercise. So here's the table that you have here. Okay, you don't have all the data. This is my solution here. So this is all empty that I give it to you there, but you don't have the data here. We need to find basically the linear regression, okay, which is based on some parameters of this. You also need to find confidence interval for the slope and intercept, and confidence interval for value at 55, the mean response, and a prediction interval at 75. Is it 75? I said actually 55. Anyway, maybe we should change this one. Yeah, so 75. Okay, anyway. How do you do that? It's quite simple, okay? First of all, if you look at the formula for beta 1 hat, beta not hat, okay? Yeah, you're gonna have this formula for before the final exam. As you can see that it depends on the value of so-called SXY, SXX. These two quantity in the class we call that variance-like formula, right? So this is their formula for SXX, FSY. So in the class, what I give is this one here. So SX equal to this, or XXY equal to this, and SYY equal to this. If you do a simple expansion in here, basically, if you expand this term, you get this one here. Let me show you how that obtain here. So for example, SXX equal to I equal to 1n and xi minus x bar square, right? So let's expand this one here. Simple expansion. Okay, so it become a quadratic term, and then plus x bar square. Okay, now x bar is a scalar value. Okay, so that's a constant there, and what we can do is we can just write this summation separately. Okay. Right now, I mean this is not, this quantity then depends on I and here. So what this quantity here, basically what input is like n times of this one here. So this is only just simply equal to n x bar square. And then this one in here, you can take the 2x bar out of this summation here. Okay, and this is nothing changed, just same as it is, right? So we basically end up with this. There's no 2 in here. Okay, so what is x bar, right? If x bar equal to 1 over n epsilon xi, summation xi, right? So basically now you can see now I can replace this, okay, with what? With n x bar. So this is 1, 2, right? N x bar here. So which become 2n x bar square. Right? This becomes 2n x bar square. And these two cancelled 1, which equal to my 1, right? Negative n x bar square. And don't forget this term here. So that's why you get this quantity here. And if you replace this x bar again with 1 over n summation xi, so you'll get this one here. Okay. Now the usefulness of this is because then you go to your Excel, you can see that is very easily you can calculate, right? You can calculate this quantity. This is xi square. yi squared and xi yi, right? And then sum of this is shown over here. So this Excel function sum. So then when you calculate sxx, right, and sxy or syy, then you can simply follow this formula over here to calculate that, because you already have the summation of this, right? So it's basically just refer to the corresponding cell, and then you will get this quantity here. Once you get this quantity, and then you can calculate the beta 1 hat. Okay, of course it'll be easy to calculate beta naught hat. Okay, so that's basically how you get all of this here. And of course, don't forget that you have 12 data. Okay, and degree of freedom is a minus 2. Okay, for regression. So now deal with this here. Okay. Formula for SSR, SSE, SST is in the lecture, so you can take those formulas, calculate the coefficient of determinant. So that's estimate of fit. That's a measure of fit. Okay, and then we can have a so-called what's the estimate of the standard deviation sigma. We call it S, right? In the class, this is basically S squared equal to SSE over n minus 2. Right? If you remember that. And S squared equal to SSE over n minus 2. Okay, SSE is the quantity, what we call the sum of the errors. Okay, so that's the sum of square of errors. So this is SSE at here. Okay, yeah. The other thing is, for this cell here, okay, for the y hat minus y squared. So you have to you can fill this cell at here once you find this beta naught hat, beta 1 hat. Okay, so this y hat at here, is basically equal to beta, this y hat I equal to beta naught hat plus beta 1 hat, and then xi. Okay, so that's how y hat is. The last 4 columns in here, okay, these are so-called basically the interval or the bounds for the mean response and the bounds for the predictions, okay, for the prediction values. So first of all, of course, I mean, you are required to calculate what's the confidence interval beta naught, confidence interval beta 1, confidence interval for the mean response. These are formula quite straightforward, and then I mean you look at the formula. This is what you're gonna get later. Okay, the beta naught with a statistic of this, whose variance is this. Okay, yeah. So you can see the quantity of these is exactly the same. It doesn't matter. So they're equivalent here. Okay. So then the confidence interval for beta naught, beta 1 are shown over here. Okay, are shown over here. So this is beta 1's confidence interval. This is beta naught confidence interval. Okay. There's an alternative writing for the confidence interval here. Okay. So anyway, so this quantity here can be replaced by this one here. Okay. Yeah. This is just simple calculation here. So you can basically this cell at here. Okay, this cell at here, beta naught, this cell at here, right? This cell plus minus this, so corresponding to this formula, and beta naught, basically beta naught hat plus minus this quantity, right? This quantity here. Okay, T alpha over 2, because it's the distribution here, and you're talking about 5% interval, 95% confidence interval, so that's T 0.025, and you can use Excel formula TINV to find this value at here. Okay, so that's how you can use that formula. So anyway, so that's confidence interval of this, and we also have a formula for the confidence interval on the mean response. Okay, The formula from that is this guy here. Okay. Yeah. Basically, this is sort of like an estimation problem too. If you look at this figure right here, this table right here, so the mean response, okay, is the unknown parameter, and then we estimated that with a statistic, which is basically our regression line here, okay, to estimate that. Okay. And we can construct a t-distributed random variable with a degree freedom n-2. Okay. So fading out of the cell according to this one here, basically it's y naught hat plus minus this quantity here. Y naught hat basically is the value corresponding to the x naught value. And in this particular case, your x naught value is 55. Okay, so you have your beta naught hat, beta 1 hat. So then calculation of this, right? That's y naught hat, which is this formula here. Okay. And this plus minus this whole guy here, and that's the same as this term over here, right? Okay, yeah. So last quantity, the prediction interval, and here prediction interval. The prediction interval, let's see. Yeah, the formula is over here. Yeah. So the prediction, you can look at the lecture notes how this is derived here. Basically, you're talking about what's the range for the predicted value y naught. Okay. The range of predicted value, it's going to be a wider range than the confidence interval for the mean response. This is a formula here. So it's still like a y naught hat plus minus quantity here, but this quantity is slightly bigger than this quantity. You can see slightly here, right? There's no 1, but there's a 1 over here. So that's why you're going to get a slightly bigger confidence for the same value x naught. So, but in this case, I should change it to 55 anyway. So this is what you're going to get here. Okay, yeah. I think I should have another one here. Yeah, that's right. This is the right one here. This is the right one. There you go. There's some redundant ones here. Okay. Yeah, that's the right one. So I guess somehow I did not delete the old one. So anyway, so this is what you're gonna get here. Okay, suppose. Last question is hypothesis testing on the beta naught and the intercept. The hypothesis testing is basically asking null hypothesis is beta naught equal to 95 or not. Okay, and the alternative is it's a two-tail test. It's beta not equal to 95. You actually can make a very quick decision before you can even calculate p-values. The reason is because if you look at the confidence interval for beta naught, so based on this sample data, the confidence interval for beta naught here is 80 this plus minus 21 here, which give us a mean value of this, which gives the minimum value of this, maximum value of this. And our null hypothesis testing the 95, this 95 is actually between this confidence interval here. So what you're going to have here actually is you're not going to reject. But if you go ahead and then testing this one here, so you need to calculate, but you still need, what you need to do is you need to calculate the test value, and then you, based on the test value, and you need to calculate the p-value. Okay, so how the test value is calculated is based on the formula we have in the class here, beta naught, which this is the test value, okay, for the beta naught. Okay, so the bottom section here, the bottom term here, see the bottom term, and that's actually the same term as this guy here. Okay, as this. You see that? This bottom term here is the same term as this term when which you use to calculate, right? Which you use to calculate this confidence interval for the beta naught. Okay. Sometimes we call this term standard error. Okay, and this is basically the variance, the estimated variance here, okay, for the beta naught hat. You can see that beta naught, the variance here, right, is this one here. Okay, is this. You replace the sigma with s, that'll be the estimated variance. Okay, so calculate test value. Okay, test the test value, and then calculate the p-value corresponding to the test value. Because it's a two-tailed test, okay, this is a negative value, so you calculate the area to the left of this value, then multiply by 2, so that'll be the p-value. Okay, so here's my calculation. I used t-distribution two-tailed. Yeah, I'm using the 2007. So if you use 2010, you don't have this one. So that's fine. T dot distribute dot to t, and absolute value of this, and then you can get the total area. Okay, on the two sides of this t naught. Okay, so it's like this, right? It's like so right now you have a negative 4.9, something like that. But you're looking for is a two-tail. So you do this total together is the p-value, right? It's the total error together is p-value. Okay, so that's the Excel here. Okay, and then you can try to fill out all the cell here, all of the points. I think once you fill it, if you don't touch any, the figure will automatically be generated. Okay, according to the data points that you calculated. So you're gonna see two green lines corresponding to the confidence interval, two red lines corresponding to the prediction interval. Okay, so as you can see that the prediction interval contains all the possible data points, right? Because it's predicting what's the possible range, right? Possible range for the response. So it's pretty wide. Okay, it's pretty wide, but it depends on the value. If your data points is a little bit more clustered and cramped together, and the prediction interval will not be as wide as this anymore. Okay, but anyhow, Excel results y and r square will be the same. Should be the same as you calculated. Okay, so that's for the first question. Okay. The second question, the second question here. Let me see the second question here. Maybe I'll talk about it. So the second is actually quite easy. You assume that your intercept is 0, and we estimate our model, right? Basically, with a regression line where the intercept is gone. Okay, so what happens is here is your model. Then we need to estimate it. Okay, we estimate it with, right, this is one here, with this guy here. Okay, with this guy here. So we estimate with this. Okay, and your original one here is this, basically y equal to beta 1 x plus epsilon, right? So then I need to come up with, using this square approach, come up with a solution for beta 1 hat. Well, it's simple because in the lecture, we have a beta naught, but this beta naught is gone. So we do the same thing, right? How do we get the beta naught hat, beta 1 hat? We create this the residual sum of errors, or the sum of the square of errors, which is yi minus y hat I, okay, square, right? Which is this guy here. Yeah. Of course, you replace the yi hat with this one here. Okay. And then what do we do, right? We wanted to basically minimize this quantity. In order to minimize this quantity, so we try to find a suitable value of beta 1 hat such that this SSE quantity is minimized. That's essentially, well, it's actually not a partial derivative, but it's just derived here. So it's actually just taking partial derivative of this and set equal to 0. The partial derivative of this is simple, right? What is that? It's don't worry about this, because when you take the partial derivative, it's basically just 2 epsilon n I equal to 1, and then this is yi, right? Xi. Okay, so 2 of this, and then inside here you take derivative of this with respect to beta 1 hat, which input is xi, and this equal to 0. So this guy equal to 0, and then you solve for beta 1 hat. So 2 is gone, right? And I don't have negative, but the negative will be gone too. So anyway, you solve that, you can just expand this, okay, and write it separately. So yi, so get rid of the negative, okay, because it's 0 there, xi, okay, and then minus beta 1 hat, okay, and what's that, xi squared, right? Okay, equal to 0. So then you solve for beta 1 hat, okay. So that's what it should be. So this should be the same as this answer here. For calculating this, that's optional, so you can take a look at the actual notes if you're interested. All right. So that's the question of this. Tutorial question, I will post a tutorial posted, but I will post a solution, Excel solution for the tutorial question too. The tutorial Excel will be pretty much exactly the same as the Excel for this one here. So I'm gonna post that on Wednesday night, maybe after tomorrow's tutorial. Okay, you can check that Excel just in case if you still have troubles there. All right, so let me know if you have any more questions, and hopefully you won't have any problems. Thank you.